In this, we're going to be talking about their counterparts, leptons. These are basically antimatter, when you think about it. Well, a few of them are. Let me explain. So, to start it off, I'm going to give you a simple definition for a lepton, which is basically a particle that doesn't have a strong interaction with any other particles or anything, which is weird because some of them are antimatter. So, let's say, like we did in the last video, I'm going to show you this. We talked about the up, down, charm, strange, top, bottom quarks. Electrons, which some of you actually might consider not gluons or quarks or anything, but actual, like, protons and neutron type things. But they're not. They're leptons. What that means is they actually have a negative charge. So they have the same, they're kind of the opposite of the up quark. But, hang on one sec. But, so the electron is basically the opposite of the up quark. So then you might be wondering, well, how come if electrons don't hit any, if an electron hits a proton, how come it doesn't explode or anything? It doesn't explode. What it does is it creates a neutron. So what it does is the electron negatively powers an up quark into a down quark. I'm just going to explain that now. I'm going through all of these. Muons and taus, I actually don't really know much about them. I don't think that anyone does, gotta say. But I believe that they are just opposites of the other ones. Tau is definitely an opposite of the top. Muon, I believe that that's an opposite of the charm also. But then here's where it gets weird. See, we're going to talk about neutrinos in a different thing. I'm actually not going to talk about this in this video. We'll get to neutrinos later, probably in the next video or after bosons. But if we were to look up a muon, and again, I'm not that good at this. I spelled it wrong. So, for the muons, what they basically do, it's actually really interesting to learn about them. But it's an elementary particle similar to the electron that has a negative charge, which is weird. Because technically, how do you get a negative charge, you know? It shouldn't be possible, but it is. That's kind of where negative numbers actually play into real life things. But it is classified as a lepton, and it doesn't have any structure per se, but muons can help detect dangerous nuclear. So what that means is if you have, let's say, a bucket of muons, the reason that they have such a big interaction with the nuclear stuff, and I don't know, it's because they have negative energy. The interaction with something of a high positive energy has a reaction with it. So that's why it can detect that sort of thing. But let's say that a muon and a electron crash together. What would happen? That's where it gets weird. So what would happen if a muon and an electron crash together is it would make a tau particle. Oh my god, this is not what I wanted. Tau physics. Okay, tau physics. So, but it is super heavy. What would happen is it would get negatively charged a lot more. They're basically an opposite of the top particle, except they have the same amount of mass. So that leads me to the next video, which will talk about some more different things. But for now, I'm signing off. Goodbye.